Welcome. In this video, I'm going to demonstrate how to find the parametric and symmetric equations for the line that passes through these 2 points. The first thing we need to do is find a vector going through those 2 points. So the vector is going to have initial point of P naught and terminal point of P1. This gives us the vector 4 minus negative 3. 2 minus 5 is the y component, and negative 1 minus 8 is the z component. So this is 7, negative 3, negative 9. And we really just need a vector and a point, and I can use either one. I don't have a point that has a 0 in it. Those are the easiest ones to use, so I'm just going to pick point P1. So I'm going to use point P1, and so the x component, let's start by actually labeling these the parametric. So the parametric equations have an x component of x equals negative 3 plus, I was looking at this point, and I said I would use point P1. So let me specify that. And you can use either point, and you'll get an equation that works. I'm just using P1. So we end up with 4 plus 7t. And instead of writing x, this is x of t. Y of t is equal to 2 plus minus 3t. And z of t is equal to negative 1 minus 9t. And these are the parametric equations. Now, the symmetric equations, these are given by solving each of the parametric equations for the parameter. So in this case, we have x minus 4 over 7 equals y minus 2 over negative 3 equals z plus 1 over negative 9. And now let me write this just a little bit neater. You can also rewrite this middle one. So I have x minus 4 over 7 equals 2 minus y over 3 equals negative z plus 1 over 9. And either works. These equations are not unique. You could have also used P naught and had different values here. If you had used P naught, you'd have a negative 3, a 5, and an 8. And similarly, this would be a plus 3, minus 5, and a negative 8 here. All right, now let's look at the segment that connects these 2 points. And in your notes, you're told to restrict t between 0 and 1. And that's in your notes directly. Now, that's if you had used P naught. We used P1, so if we want to go from P naught to P1, well, let's look at this equation. What does t equal in order for 4 plus 7t to equal negative 3, because that will get us the point P naught. If you said negative 1, you're correct. So for P naught, t must equal negative 1. And if you notice, 2 minus 3 times negative 1 is 5, which is our y component. Negative 1 minus 9 times negative 1, well, that's going to give us a positive 8. And that indeed is the z component. All right, now to obtain the second point, all we really need to do is make all of these vanish, all the t values. So that means t equals 0, and that'll get us 4, 2, negative 1 here. So in our case, since we used point P1, you restrict t between negative 1 and 0. And so on your own, if you'd like to verify in your notes how it tells you to restrict t between 0 and 1, you can use P naught here instead of P1 to get different equations. And the restriction here would not work. You would need this restriction to get the segment. I hope you found this video helpful.